File handling is an important part of any application. Files can use many different extensions such as .txt for text files, .csv for comma-separated values like rows and column files, or .dat for data record files. The extension does not change how Python opens the file. Python reads the file based on its contents. Python has several functions for creating, reading, updating, and deleting files. The key function for working with files in Python is the open function. The open function takes two parameters, file name and mode. There are four different methods or modes for opening a file. R, which represents read, is a default value, opens a file for reading, and an error occurs if the file does not exist. A, which stands for append, opens a file for appending and creates a file if it does not exist. W, which stands for write, opens a file for writing and creates a file if it does not exist. X, which stands for create, creates a specified file and returns an error if the file exists. In addition, you can specify if the file should be handled as binary or text mode. T, which represents text, is a default value for text mode, and B, which represents binary, is binary mode and useful when handling image content files, for example. We can create a file, like here in this interface, by clicking a new file and calling it something like demo file with an extension like the txt for text file. And then we can fill it with some regular sentences as content. Now, to open the file programmatically through Python, we can use the built-in open function. The open function returns a file object which has a read method for reading the content of the file. For example, we can specify a variable f and set it to the open function and specify the file name as the argument. In this case, the file name is demofile.txt, so we specify exactly that name as the argument. Then we can use the read method to return the whole text in the file. To do so, we can say print f.read. Now, when we run the program, we'll get the contents in the file printed out, line by line. R and T are the default values, so we don't have to explicitly specify these modes. And we'll get the same output regardless. Now, suppose that you misspelled the file name here in the argument of the open function. Say maybe we remove the E. When we run the program, the open function is not going to be able to find the file because this name does not exist, at least in the context of this interface. So we get an error, file not found error. Also, if you're working with files locally instead of an online compiler like this one, normally your files might be located on a local path like this. Maybe the D drive, / under some folder like my files, / the file name like demofile.txt, for example. So make sure you specify the correct path for the file if you're creating files locally. Now, by default, the read method returns the whole text, but we can specify how many characters we want to return. For example, if we just want to return, say, hello, this would be the first 5 characters in the file. So then we can specify here in the read argument 5, and this will return for us hello. We can also return one line by using the readLine method instead of the read method. So we can say f.readLine. Now, when we run the program, we'll get the first line of the file printed out. If we call the readLine 2 times, we can actually read the first 2 lines instead of just the first 1 line. And now we'll get the second line also printed out. Notice there's some new line here in between the first 2 lines. So if we want to avoid having this indented extra line here, we can specify a comma and end equals empty string here, and when we run the program, now we don't have the extra new line anymore. We can also loop through the lines of the file and read the whole file, line by line. To do so, we can say for x in f, print x. Now when we run the program, we'll get each line in the file printed out. Now, so far we have explored a file with regular sentences as its content, but sometimes a file may not contain full or regular sentences like this. Instead, each line may store a record, for example, something like this, where we have a record of names, maybe a department, and some score. Now, this would be considered a structured file where each part of the record is separated by what we call a delimiter. In this case, the delimiter is a comma, but delimiters can also include other types like pipes, for example. However, the most common is commas, which actually alludes to CSV type files, comma separated value. But we can also have comma separated value in text files as well. Now, to work with a structured file like this, that's separated by a delimiter like the comma, we can loop through the file line by line and split each record. So for example, we can say for line in F, and then we can say line equals line.strip, and the strip method here is removing the new line character from the end of the line. Next, we can specify a parts variable and set it to line dot and use the split method. We use the split method in order to separate the line into pieces wherever there is a comma. So we're separating by the comma delimiter. If we have a delimiter like pipe instead, then we would separate by the pipe. In this case, the file is delimited by comma, so we would be separating it by comma. Now each piece can be accessed by its index. For example, if each record contains something like the name, followed by the department, followed by a score, then we can specify a name variable and say parts 0, department variable, and set it to parts 1, and score variable, and set it to parts 2. Now the reason this is possible is because, remember, strings can be indexed just like other data structures. And lines and files are technically strings. So essentially, that's why we can index them part by part. Now we can print them. So we can say print name, print department, print score. Now when we run the program, we get name, department, score, name, department, score, name, department, score. Each line separated by part like this. By the way, it is a good practice to always close the file when you are done with it. To close the file, we can use the close function. So at the end of the loop here, after the loop, we can say f.close, run the program, and you may not notice anything different, but something actually happens behind the scenes, and it's a good practice generally speaking. In some cases, due to buffering, changes made to a file may not show until you close the file, so it's a good practice. An alternative to explicitly closing files like this after processing the file is we can use the with statement here. So we can rearrange this here and say with open, and after this we can say as f, and then we need to indent this for so it can become part of the with statement scope. Now when we run the program, we'll get the same output, and by default the file would have closed. Now let's discuss writing to a file. For simplicity, I rewrote the regular sentences instead of the delimited values that we had, and now we can see how we can write to this file. So to write to this file, we can add a parameter to the open function. Remember, A stands for append, which will append to the end of the file, and W stands for write, which will overwrite any existing content. So if we want to append content to the demo file in this case, we can add here an A mode for append, and then we can say something like f.write. Now the file has more content. So now when we run the program, you won't see anything in the output here, but we'll see that actually we added a line to the file. Now the file has more content. Now we can open and read the file after the appending. Again, we can specify the with statement, say with open demo file.txt as f, print f.read. Now when we run the program, we'll get the content in the file printed out to console as well. Now notice when I ran it again, it actually appended the same line once more. So every time we run the program, it will just keep adding and appending because we specified the A for append. So it's not overwriting, it just keeps appending and appending and appending. So if we want to overwrite the content instead, we can switch from A for append to W for write. And now when we run the program, we'll see that the file has been overwritten. And if we run it again, it will keep getting overwritten every single time. Now, so far we have been opening an existing file and reading from it, as well as writing or appending to it. But now let's explore creating a new file programmatically through Python. Recall, to create a new file in Python, we can use the open method with the following parameters: x, a, and w. X for create, a for append, and w for write. So we can create a new file called myfile.txt like this: f equals open myfile.txt, and specify the X mode for creating a file. Now when we run the program, you will see that a new file was programmatically created by Python. Now if we run the program again, we'll actually get an error because the file already exists now. Now, after we have created the file programmatically, we can open it using the W mode for write or A for append, and use the write method to store data inside the file. So let's say that we want to store the following variable values. Let's say name equals to Alice and score equals to 90. So we can say f equals to open and specify the file name, myfile.txt, followed by W for write mode. Then we can specify the write method, so f.write. And here we can write, for example, name and concatenate the name variable using the plus operator. And we want a new line to print the score afterwards, so we can concatenate a new line. Now next we want to also add the score to the file. So we're going to say f.write score and concatenate the score like we did for the name. However, keep in mind here that the content of the file is normally strings. So when we are writing to the file, we're writing strings, but the score here is an integer. It's a number. So we have to cast it. To cast it, we can say str and pass in the score argument. And of course, since we're not using the with statement here, it's a good idea for us to close the file afterwards. So f.close. Now, when we run the program, of course, we're going to get the error file exists. So let me first delete the file that we had already created previously. And now let's run the program again. So now we'll see that Python recreated the file, myfile.txt, and we'll get the name and the score added to the file. By the way, instead of concatenating strings, we can use formatting using fstrings to make the code cleaner like this. This way, we actually would not have to cast numbers like we had to do for the score when we were concatenating instead, because formatted strings or fstrings automatically handle conversion. Now let's explore deleting files. To delete a file, we must import the OS module, import OS, and then run its os.remove function. So for example, we can say os.remove and specify the name of the file. Like let's say we want to delete demofile.txt. And then run the program to delete the file. Now, you may notice here that the file still technically exists. So why is that? Why didn't it delete the file? Well, files manually uploaded or present in the editor in online GDB, for example, or other online IDEs may be readable, but deletion via code may not be fully synced with the GUI or the user interface. So as a workaround to ensure deletion in the IDEs like this, it's helpful to create the file programmatically using the right method. So I'm going to delete the file and we can create the file first like this. And now when we run the program, you'll see that actually the file was created and then it was removed instantly afterwards. And you can actually see that the file would be getting created if I quickly remove the remove from here, run the program, and you can see the file gets created. So if I add the remove again here and we run the program, you will see that at some point the file was created and then immediately removed afterwards. And the reason for that is because they would exist in the online GDB runtime, the IDE runtime, which makes it fully accessible and deletable right away. Now, let's say that we try to remove a non-existent file. Again, I'm misspelling the file here intentionally to reproduce an issue like that. You will see that we'll actually get an error, file not found error, no such file or directory, because the file that it actually created is demofile.txt with the right method. And so it's not able to find this file that's missing an E here. And so to avoid getting around these file not found errors, we can actually implement a check to see if the file exists. And this doesn't only apply for the removing files or deleting files. We can also implement it with other use cases that we've seen previously where this error was occurring as well. So what we could do is we could say if os.path.exists demofile.txt, then remove the file demofile.txt. Else print the file does not exist. So I'm going to delete the file quickly that we have created here. And you'll see actually that the file did exist because it created it here. And then at some point it ran the check and it found the file existed and deleted it. But let's say that we actually opened or created a different file, let's say like demo file 1 and run the program. So you'll see that we get demo file 1 created, but now when it tries to delete demo file, well, there was no demo file created. It was actually demo file 1, a different file completely. So we can see here that the check ran and it checked that the path actually does not exist for a demo file.txt. And so it printed the file does not exist, which is the else condition here.